Hey guys, how's it going? So today actually we're gonna go through machine learning type of problems. So these are not only machine learning but data science in general, right? So yeah, I thought these problems are quite interesting, and some of these problems have been asked by companies like Google, Facebook. So yeah, let's see how we can actually go and solve them. So the first question. By the way, before we start, I just want to say this will be a bulk of question. So I think we're gonna solve like 5 questions or so. Just let me know if you guys like this style. I like to solve them in bulk. If you don't like this style, I can solve them. Like I can create one video for one question. That's okay. Anyway, so the first question is normalize grades. So we're told that we're given a list of tables featuring names and grades on the test. Write a function normalize grades to normalize the values of the grades to a linear scale between 0 and 1. Okay, so I think the question is quite straightforward in that we have to take these grades that were given for these students and we need to normalize them in such a way that the normalized values range between 0 and 1. Okay, so let's go to whiteboard to explain these concepts. So there's definitely a technique for normalizing values in data science in general, right? So we have techniques such as normalization, right? Standardization, right? So those are like the techniques that we use to normalize the values. So usually we will normalize this values in machine learning. Uh, that is because we want, if like we have these numbers that ranges, like let's say you have a column that has amount, right? And you have another column that is maybe quantity. So amount, it ranges like from 1.5 and quantity it ranges from maybe 3, 5 to something like that. So your model will then, if it's using these features, it will then weight the amount more than the quantity because of these values. So the technique that we use is that we want these values to be on the same scale, so to speak. So that's what we do in machine learning, right? So because of we are told in the question that we want the values to be 0 and 1, so this, if like you are really familiar with these techniques in machine learning, you will know that normalization will be a good technique because it tries to clip the values between 0 and 1, whereas standardization takes x, which is a value, and it tries to subtract by the mean of like x values and then divide by the by standard deviation, right? So that's like the formula for standardization. Then with the normalization, so I think they might be asking you this question because they want to know if you know these formulas. I'm not sure, but yeah, if they didn't mention these formulas, but you're gonna need them anyway. So with normalization, what we do is that we take the x and we have to subtract it with the x mean, right? And we're gonna divide this with x max and we subtract x mean. Okay, and this is the formula for normalization. Okay, now with this in mind, how would we then go about solving this, right? We can see that we're given the grades and we're given the output. So we can see that okay, they have been normalized 0.9, 0.68. So how would we go this? My thinking process before we start is that we're gonna create a function to kind of like normalize the values for us, like given x, like please normalize it for us. Then what I'll do is that because of you saw from the formula is that I will need to get x, the max value and the minimum value. So we're gonna need to calculate those from this array. Then when I'm done is that then I'll pass these outputs. I'll create another for loop to loop through these elements and pass them in that function that I spoke about, which is normalization with the derived x max and x min, so that we can complete our equation. So I know that might be confusing, especially I did not actually draw this on a diagram. So I think if I start writing code, everything will start making sense. So let's create a function called normalization. I don't know, I think the US they use Z, then UK, South Africa we use S. I'm not sure, but yeah, that might be the case. But anyway, we're gonna take an X, which is, you can think of this as a grade. Then we're gonna need to take an X max, as you saw in the equation, and we're gonna also have to take X min. So what we do then is that we're just gonna have to return X, we subtract this by X min, right? And we're gonna have to divide this by X max, then we subtract by X min. Okay, given this, and now coming to the main function, we know that we're given these grades as an array, and each element in the array is a tuple. So what we're gonna do is that we're gonna have to iterate through, because remember that we're looking for the max. So one way we can do this in an efficient way, in an of n, right, without like literally wasting any space, because one could have said, okay, maybe we can store these into a hash or something like that. Instead of doing it that way, what I'm going to do is that I'm going to loop through this, and I'm going to create variables called xmin and xmax. So I'm going to have xmin, sorry about that, which is going to be xmin. This is going to be, so we know that the minimum value, like because these are grades, the minimum could be, assuming it could be maybe 100. Maybe let's say everyone got 100. So I don't want to write 100 here. I'm not sure. So the best thing that I'll do is that I'll write float infinity. So it's a positive value. So I'm just going to do that, because we know that anyway we want the minimum value. So this we're gonna anyway overwrite this. Okay. So we're gonna say x max. Also, like we know that we're gonna say float int infinity. I think it's infinity. Actually, it's negative infinity, right? So what we're gonna do is that we're gonna then loop through the grades for grade in grades. So this is essentially is gonna cost us. This is not each operation is gonna cost us O of n to iterate through this, because we're looking for the maximum value in this array, right? There's no way you can get to that by just saying max, because they are embedded inside a tuple. So what we're gonna do is that we're gonna say x min is gonna be equals to the minimum of take the grade, and I'm just gonna look for the first one here refers to this, because you know in Python we start with 0 and we go to 1. So I'm saying take the grade, which is 1, and then passing the x min here. So what we'll do is that we'll then compare if which one is the minimum, because we remember that we want the smallest from this tuple. So this function here is just going to make sure that we get the minimum. So the minimum here is 38. So that's the guy that we're looking for. So as we go through this for loop, it's going to keep overwriting this value, because for instance, it's going to say, oh, 94. Okay, that's not small. But for now, it's going to be small because the first one is infinity. So it's a very, very large number. So it's going to write 94. It goes here and say, oh, 80. 94, you're not the smallest. 80, you are the smallest. It comes here and say 38. Oh, 8, you are not the smallest. 38, you are smallest. It go 48. It's like, no, no, no. We have the smallest, 38. So it's gonna do something like that, right? So that's what I mean. So we have X max, and we're gonna take the max, which is the same concept, which is we take the grade. We're just looking for the max value. So we're gonna have grade 1, and we're gonna say X max. So this technique here of saying max, it says that given this current element and the previous element, take the max value. Yeah, that's what it does. So I'm gonna have to create another space. I'm gonna have to create space because what I'm saying is that I can't override this. So I can't override it because the tuple is an immutable data structure. So what I'm gonna do is that this thing is gonna force me to say output equals to this. So we know that space complexity now is gonna be O of n because of this. So what I'm gonna do is that I'm gonna look through the grades for grades in grades, right? So we're gonna take outputs, right? We're gonna say append. So what I wanna append is that I wanna pass in the name. You can see here we have the name. So firstly we have a table. Then I'm gonna say grades, grade, right? Take in the name, which is at index 0. Then I want the normalized value. So take this normalization function, okay? And when you take it, I want you then to pass in grade as our x, okay? And then I want you to pass in, we have x max, so we're going to pass in x max. I want you to pass in x min. So this guy here is going to normalize it. So we're going to have something like this. So when we're done, we're going to return the outputs, okay? Because of this, it's also O of n. So what we do is that we're going to take this O of n plus this O of n, which is going to give us 2 of n. Then because of constant, we don't include constant, so the overall complexity is going to be of n. Then the overall complexity of like space is also going to be of n. Yeah, let's give it a shot and see how it goes. So it says here unsupported. Can I actually do this? So assuming these are grades, so we assume that the minimum grade will be 100, so it's fine to say 101. Assuming that the maximum grade that one can get in an exam is 1, so to say -1 is still fine. So let's run this. Did I make a mistake? So I think this is the problem, right? So we're passing the list instead of passing the actual value here. Sorry about that, guys. And the solution works. So I'm just gonna submit. Yep, and it works. So yeah, let's go to the next question and see how it works out. Question number 2, we're looking at tag counter. So they say that you are asked to develop a simple tag counter that will look for the occurrence of certain words or phrases in a piece of text. You're given a paragraph as a string and a list of tag groups as a list of strings. Write a tag counter function that returns a list of integers with the number of times each tag in the tag group was used in the text. Yeah, that is mouthful. So, but anyway, what they're saying is that, so we're given these text groups, then we can think of like we have tags. We need to search these tags inside this text. So for instance, if we take a look at the output, we can see that that first tag, there is occurrence of 1. How is that possible? So if we scroll to the right, we're supposed to see data scientist or data analyst. If I'm not, and there we are. There's it here, data scientist. Do we have data analyst? Nope, because there was only one, which is true. So essentially, you search this text inside here, then you count for this tag how many occurrence did you get, right? So my thinking process in this case will be like, we go through the tag to get the tag, right? We go through the groups to get the tag, then we go through each tag and we search the tag inside this text. Then what we do is that we have a counter to count how many times this has been detected. So we're gonna say something like, how many times does this thing occurs from here, right? So I'm gonna show you now. I think it might be confusing, but I'll show you in a sec how it's gonna go about it, right? So we're gonna have the results, which we're gonna store the final results for. So my point was that we're gonna say for group in tag groups, then what we want to do is that we're going to have a counter because they want a count. So this count essentially is going to count how many times for each tag did we found this. So then we say for tag in our group. So what you can think now we're doing is that we're saying in this group we're getting this tag, right? So we are told that your function should be case sensitive with regard to the tag. So what we need to do in this case is that we need to say if tag, right, dot lower, right, is in text dot lower, right? So we're doing this lower, so because of if like we have data scientists written in caps and the one in tag, then we might actually face a problem. It might not be detecting. So I'm just gonna say count plus equals to 1. Okay, so you can think of what I'm doing here is that I'm saying get a data scientist, check if it's here. If it's here, increment by 1. Go to data analyst, check if it's here. If it's here, increment by 1, something like that. So then when I'm done, what I want to do is that I want to get this count because we are doing this for each group. So what you want to do is that you want to say results dot append the count. Then when you're done, you're going to return the results and this should work. I'm going to submit to test all the other test cases and it works fine. So yeah, I think this was pretty much a straightforward problem. And yeah, so let's go to the next question. So now we're gonna look at matrix analysis. I wanna say that one thing that I forgot to tell you guys was that I think for data science and machine learning type of questions, you might be asked to solve them in PyTorch. You might be asked to solve them in NumPy. For loops in Python are quite slow, and these libraries have been optimized for working with vectors, and they're very fast because I think some of these libraries are written in C. So it's a good idea to solve some of these problems using those packages. So yeah, I just wanted you to know that, something that you should keep in mind. So with regarding to this question called matrix analysis, we are told that let's say we have a 5x5 matrix, number of employees where each row is a company and each column represents a department. Okay, So each cell of the matrix displays the number of employees working in that particular department at each company. So what we need to do is that we need to write a function, find percentage, to return a 5 by 5 matrix that contains the portion of employees employed in each department compared to the total number of each employees. Okay, so that was quite mouthful. So I think, as usual, what I would like to do is that I would like to kind of like show you what they actually want. So they telling us that they give us a matrix. So you can think of it this way, and the rows are the employees and the columns are the department. So each cell, each cell, you can think of it as number of employees. So let's say here it's 5 for this department, no, 0 0. Maybe for the second department is 10, for the third department is 2, for the fourth department is 1. Here it's going to be maybe, I don't know, maybe 10. Right? So the point is that they want you to then return the percentage of employees per department. So for instance, for this row, you're gonna get the total, right? And you're gonna divide this element, this total number of employees, by this total, right? So we have what here? We have 10, 20, 22, 23, and 28. So we're gonna say 28 divided by 5. Then you insert this number here. That's what they say essentially. Okay. So how would you then go about solving this? What is our thinking process? So definitely when we have a matrix and we wanna go through each element, right? Because of it's a matrix, it's a 2D, so we're gonna have to iterate it from a row and column perspective. So the first thing that we can do is that we can store the length of the row and the length of the column. Then what we do is that we then loop through. Firstly, we loop through to get the totals. Like we wanna get the total of each row, right? We get the total of each row because we know that we're gonna need to divide by that total. So by that total. But the question is, how, after we get the total for each row, we're gonna have to store it into a hash map, right? So then we're gonna create another for loop now to go through each cell. So now when we go for each cell, what we're gonna do is that we're gonna take this element, we're gonna divide it by the total for this row. So how would we know that total is for this row? Is because we're gonna store that total with the index. So for index, for example, this is the first row, so it's the row number 0, this is row number 1, so forth. I know I just confused you, but trust me, when I start writing this code, everything will just clears up, right? So yeah, so that's the thing we're gonna do. So like I said, the first thing that I like to do is that I like to get the length of rows. So you can think of like we're getting like, we want to know like the length of rows, right? It's because if it's a matrix. So we have col, which we're gonna get the length of number of columns, which is employees 0. I know this might be confusing for some of you if you're new to maybe matrices. So essentially what we're doing is that we have a matrix, right? Like in Python, like these things are stored like this. Actually, let's do that. Let's not write them in the table. So they're stored like this. They're stored in more like an array, right? So they're stored like this. So what is the length of the row now? For instance, we know that it's 3. Like if not starting from 0, so it's 3, right? So how did we get 3? It's because we counted the number of arrays here inside. So that means we have to say length of employees, right? That's it. Now I'm gonna ask you the second question. We have columns. How do we know how many columns are there? So let's say we have two numbers: 1, 2, 3, 4, 5, 6. Right? How would you get the number of columns? You can just take the first array. You can take the first array, then you can say the length of this. So it's gonna give you 2. So that's what we did. We set length, employees, and we took 0 here. So yeah, I hope that kind of like give you sense why we get column and row. Okay, so now we have columns and row. The good thing is that we can get the total, like we want the total for each row. So how can we do that? We can say for R, right? For R in range of row, right? And then we can then say that we want, what's this? We want to say, actually let's do this. Let's just say, I'm gonna assign total because like I said, I want the hash map so that the second for loop can be able to index this. So we're gonna say total R for row number 0. We want it to be to sum employees, because now I'm taking that array, so it's gonna sum that array, those elements in that array. So I'm gonna be having this total which has something like this. So you can think of it as like it is 0, the first row has 45, the first row 1 has the total of 500, something like that. So that's what we're doing. Okay, so now what we want to do, we have the totals, we loop through each element. So we're gonna say to loop through each element, because of this is a matrix, we're gonna have 2 for loops because it's like the row and the column. So you say for row in range of row, okay, then you say for column in range of col, okay. Then now you say employees, you take the row and you take the column. You're targeting a specific value in the matrix. So you're gonna say equals to employees, then you take a row and column. I want you to divide it by total row. So I'm taking that row index and I want to actually be able to total this. So now when I'm done with this will be able to return the correct result. And it does. But like I said, we're creating a space here which is not for free, so which is gonna be what is this, of n, and we're creating a for loop which is we're looping through the row. So this is gonna be of R, right? Of R, right? And this, because it's a matrix, so this is going to be of R by C. So this is more like O of n, but for matrix we're going through each element in a matrix. But anyway, but the point here that I'm raising is that how can we optimize this to be more efficient using some of the machine learning libraries, and we can leverage those vector libraries that we are used to. So let's do that and see if we can actually optimize it. So I'm just gonna try by all means to erase this or highlight it. It's not necessarily a bad solution overall. So what we want to do is that because in machine learning we work with matrices, we work with like vectors, that's what we do, right? So that's why the solution now will look more alive. So we're gonna take np dot array, and what we do is that we're gonna pass in the employee. So we're taking the matrix as it is because we want to divide each element by the sum. So we're gonna say divide by np. So we wanna take the sum of the employees. So we're gonna say array and pass the employees, but we wanna say dot sum this, but sum it across the axis, now the row wise of cost to 1. Also, what we want to do is that this here should be able to match with the column here, should be able to integrate well with this matrix. So to make sure of that, we're going to pass this thing called dot shape. I think it's dot shape, dot reshape, I think. We're gonna say figure out the row. We don't know the number of rows, but we know that we want the column to be 1 because we want one column. We want the total only. So so you can think of, I'll show you from a visual perspective. Then I'm just gonna return this. I'm gonna run this code, and it works. And it was line 19 of code. But what just happened there? What did we just do? So let's go to whiteboard. So what you can think is that we had a matrix like this. Oops. Let's scroll down. So we had a matrix like this, right? Like we saw, right? And what we did was that, okay, we're gonna create the total of each row, and we're gonna convert this in a more like to have one column, and we just said -1 to figure out the number of row. So this, maybe it's 500, whatever. Then we had all of the numbers the way they were, maybe like 5, 10, something like that. So we said take this matrix and please divide it by this values inside here. So it did an element wise division. So it took 5 divided by this for this row here, something like this. Then this we divided by this. For this was divided by this. For this was divided by this. That's what it did. So yeah, that's like that. So let's go to the next question. So now we're gonna look at the scramble tickets, right? So this question states that we should consider a trip from one city to another that may contain many layovers. Given the list of flights out of order, right? Each with a starting city and end city. Write a function plan trip to reconstruct the path of the trip so that the trip tickets are in order. So in simple terms, you can think of like we have this flight, and these are trips like from point A to point B, right? So but however they've been shuffled and they're not in order. So by in order, I mean they should be something like this. You see here we say coming from Bombay to Delhi, right? Delhi is the destination, right? Then Delhi becomes a source. Then we go to Goa, Goa becomes the source. We go to Chennai, Chennai becomes the source. We go to Bangalore, which is a destination, Bangalore becomes a source. We end up at Beijing. That's what we call an order. But if you look at this one that we've been given, it does not have an order. Bangalore, no, there was supposed to be a Bangalore here. You see? So with that in mind, how would you then solve this, right? So one way you're probably thinking is like right, we start with the brute force, obviously. You might be like, okay, how about we loop, like say for instance, we say for trip, right, in trips, right? So we accessing this component here, we're accessing this guy, then we say for, I think we're gonna say for T in trip, maybe, or for CT in trip, right? We're accessing this guy. So maybe let's say we want the second guy, for instance. We want to get this guy because we want, if we have this guy, we can then, if we have the destination, we can be able to know that, okay, we have to look for the source, right? So we're gonna end up with multiple for loops, as you can see. So in short, this is not efficient, right? It's gonna lead us to not an optimal solution. So how can we then solve this question in time complexity of O of n, right? So my thinking process is that we can solve this problem by having two dictionaries, right? So we can have one dictionary to store the source, and we can have another dictionary to store. I'm gonna explain the intuition behind this. Just follow with me now. You're gonna understand why I'm saying we need two dictionary. So I'm gonna tell you the intuition. So we're gonna have two dictionaries, like so. Then what we're gonna do is that we're gonna populate them by the source is gonna have these things here on the left. Then the destination is gonna have these things here on the right, right? For instance, we're gonna say for trip in trips, right? So we know that trips has two elements. So we're gonna say destination, which is this dictionary. We're gonna say take the trip I, right? So we're saying take the trip I, which is I. We know that 1 is equals to this guy here. So we say you're gonna say equals to trip 0. Okay. So what I'm doing here on destination is that I'm giving it Bangalore and I'm mapping it to source, which is China. And similarly, I'm gonna do the same thing on the source. I'm gonna say source, which is trip 0, right? By 0, I'm accessing this element here. This is 0, this is 1 in Python, right? So I'm gonna say take trip 1. So what I did here was that I said Chenena, something like this. Chenena goes to Bangladesh. This is how it will store them. Does this make sense? So I want you to understand that this is how we're gonna store them. Okay. The second thing that we're gonna do, this was number 1. The second thing that we're gonna do is that we're gonna have to have a start. We need to have a start because here we can see that there has to be a start where we started. Remember that this thing here that we're constructing, it's like a trip. We started at this point, we went to this place, we went to this place, we went to this place, but there has to be a start. That's the point. There has to be some sort of like a place we started. But how do we know a place that we started from? My intuition is that to get a start city or a start place, right? A start place will never have a destination. Was never a destination. Yeah, sorry for confusing you. Yeah, this will be this is the right way to say it. Was never a destination. Was never a destination, right? Because we never went there. That's the start. So was never a destination. Okay. So for instance, if we take an example, let me scroll. My OneNote is acting up. Sorry about that. So if we can look at this point, what is the start? So we can see Chennai is as a destination. Bombay has a, yep, we got it. Bombay is the start. You see, it does not have a destination. So that's what we're gonna do here. We're gonna find the destination, the starting place. So we're gonna say for a source, right? For source, in, I think we wanna say source items, right? So we're gonna say for source in items, then we're gonna get we're gonna say source, right? Then if the source are not in destination, what we want to do is that we want to say start equals to source. So essentially, I'm going to write the beautiful code. I think OneNote is acting up, but the point here is that I'm looping through the source just to make sure that I only get a start places where it does not have a destination. So that's the intuition essentially. But as we write the code, you will get to understand it. So what's the final part, right? Now this is where you get to understand the power of those dictionaries that we spoke about. So what we want to do is that we're gonna go from I to the length of source, right? And what we want to do is that we want to get a destination. Remember that we need to return. Don't forget this. We need to return source and destination, source and destination, but they must be in order, right? So we're gonna say, okay, we're gonna say source. We want to know the destination of the start place, right? We just computed the start place now, right? We want its destination because we're starting from fresh. Remember that we're constructing this. Then I'm using this dictionary because the dictionary is gonna tell me the destination. Don't forget that about those dictionaries. This thing is gonna give me a destination, right? Now look at the beauty of this. I'm gonna create an empty array, and I'm gonna say results dot append, right? The start place, right? Which is this, and I'm gonna append the destination. Then what I do is that I then update the start place. I'm gonna say the start now becomes the destination, equals to destination. So when we go back, literally when we go back to our loop, right? It's gonna say the start place now. For example, let's say we start A and B. B now is our destination. It's gonna pass B here. It's gonna say what is the B destination? Maybe the B's destination is C. So it's gonna do that. But the point here is that we're reconstructing this in a much more beautiful way, and the solution is solving O of n. Obviously, we have a space because of those two dictionaries. Right? I think I might have confused you on this one, maybe with this, but no, I would like to kind of like code it up, and you're gonna get a better institution, right? So, so I'm gonna create the two source. Why are we creating these source? We're creating these two dictionaries because we can be able to say, for instance, if we want to know the destination of a specific source, we can just pass that destination and it's gonna tell us, right? So that's that. So we're just gonna have to populate this. So I'm gonna have to create one for loop in flights, right? Then what I do is that I take the destination, I say trip. So here you can think of like I'm accessing the destination. So I'm accessing this one here, and I'm assigning it. I'm saying take trip 0. So given a destination, it will give me its source. Similarly, given the source, if I put trip 0 here, given the source, you will give me the destination. Okay, as easy as that. So now I want to get the start trip. Why are we getting the start trip? It's because we have to start. You can think of it as a snake, right? You have to get a start, right? So you think of it as a snake. Otherwise, like where would you start? So you have to start somewhere, right? It's a trip, right? So, but the intuition here, it's beautiful, is that a trip will never be a start, will never be a destination. So that's what we're gonna do. We're gonna say for source and destination in the source dot items. So you can think of this, and I'm accessing the key. I'm accessing the key and the value from this because we just loaded this. Okay, so what I'm gonna do is that because now we have the source, I'm gonna ask if the source not in destination, then I know that's our guy. I know 100% that's definitely the start trip. So I'm gonna say equals to source. Okay, I'm gonna iterate. I want you to understand. I'm gonna repeat this. For instance, if you look at Bombay here, it's not in here because why? Bombay is the starting guy, is the starting trip. So it's similarly with Beijing. You see, it's an ending trip. It's where we end. So it will never be inside here a start, right? Unlike these other places, you see here it's a destination, then it becomes a source. This becomes a destination, it becomes a source. Okay, so I hope it makes sense. Okay, guys. So now we're gonna have to send our results when we're done. Then I'm gonna say for I in range of length of, I think you can also take the source, but it's fine. Then you can say source. What I'm doing here is that I'm gonna say destination. Remember that the results want source and destination. So now this is where now this is where the solution works. It's like saying that given the source, I want to know the destination of the start trip, right? I want to know the destination. I know the source here, but I want to know the destinations, and I can use this dictionary, the source. I can say, give me the destination of this guy, start trip, right? Now, the beauty is that we have the start and the destination. So why not append them? We're gonna append them, start trip and destination, right? You can think of like we are appending Bombay and Delhi. How did we get Delhi? We got Delhi because we just asked the source, given the start trip, where is the destination of Bombay, and it told us it's Delhi because we did store these things inside here. Okay, okay, now because we're iterating through this, we need to update the start trip. The start trip now becomes destination, right? It makes sense because you can see here destination will become a source, destination will become a source. Okay, so hope it makes sense, guys. Okay, and now I'm gonna submit, and it works. So that's the solution, guys, and that's how I kind of like thought about it. And yeah, let's go to the next question. Okay, looks like we have a probability problem here. So it says that nightly, they call it nightly job. Say every night between 7 p.m. and midnight, two computing jobs from two different sources are randomly started, with each one lasting an hour. Okay, unfortunately, when the two jobs simultaneously run, they cause a failure in some of the company's other nightly jobs, resulting in a downtime for a company that cost $1,000. The CEO, who has enough time today to hear one word, need a single number representing an annual cost for the problem. Okay, so just to kind of like give you a high overview, so what they're saying is that every day we have two jobs that run, and they run from 7 p.m. up to like 12 p.m. Or midnight. So what's going on is that if these processes start at the same time, or maybe the other one start while the other one is still in process, then this is going to cost some sort of like a downtime, and this downtime cost the company $1,000. So what they want is the CEO want to estimate how much this cost will be for the whole entire year, right? So maybe that was confusing. So let's kind of like simulate this in a more clear way. So let's say we have let's say we 12 p.m. and 7 p.m. all the way to midnight, right? So every day we have a job that runs 1 hour. So we can think of like a job start here to 8 p.m. Right? It's done. However, if we get another job that start while this started, maybe this one goes to started at half past. This one started at 7:30. It goes to 8:30. Right? 8:30. This here is gonna cause a damage, or what is it they calling it? Yeah, slow down or whatever. But it's gonna then cost the company $1,000. So when these processes run like separately, like let's say this one start and the other one start here, it's fine. This one cause a damage, right? So, but the CEO want to estimate that for the whole entire year. Remember that this is happening a day every day. So what they want to get an estimate of like how many times can this thing happen, right? How many times can it happen, and what will it cost us? Can this okay? And what cost will this have on us, ne? So so we need to calculate the whole entire thing. So how can we do this, right? The thinking process. So one way we can go about this is that obviously we know that we have to simulate this for 365 days, right? That's one aspect of it. But then we need a way to randomly start this process, because they said they start at any time, right? So we need to build a function that randomly start these two processes. So for instance, we're gonna say random. They did not mention the specific like time granularity. So I'm gonna assume that they are talking about seconds. So what I'm gonna do is that we're gonna build a random function which is gonna start job A. So we're gonna job A and job B. So this random function is gonna give us a random number, because remember this is a probability. We're trying to estimate the whole entire cost on average. So what we do then is that we get we try to get the time from zero, because of I said like this will be in seconds. I'm gonna say 5 from 7 to midnight is gonna be 5 hours times 60 times 60 minutes and seconds. So this will give us 18,000. So this will then generate any random number between these seconds. So this will more or less simulate the start of the job, right? So if this one started any second, it's fine. If this one started any second, it's fine. But what we want to do is that we want to take the start time of the first process and the start time of the second process, and we then want to subtract these two. So we're going to say something like ups A subtract B. And if the difference, remember that I showed you now that if they're within this 1 hour, there have to be like this one started in an hour, and this one also, you see, it's in this hour of the first job. So what I want to do is that I want to make sure that there is a gap of an hour between these two processes. So which means that I'm going to subtract A and B. I'm going to say if this is actually less than 360, I think this is an hour, so it's 60 by 60. So it's 3.6. If this is the case, right, we're going to increase an overlap. Right, we're going to say interruption. You want to call it interruption, it's fine. So we're going to increase the interruption by 1, because that means these two are running in the same hour, or maybe not but maybe there's an what is it? What do they call it? Overlap, so to speak, between these processes. Okay, so that's why we're doing this. So we're gonna try to do this for each day to see how many times of the interaction we will get. So we're gonna have something like 4i up to the way to 365, right? And we're gonna try to see how many interaction we can get. Then when we get these interaction, because each interruption cost us 1,000, we're gonna accumulate these interaction. Then we're gonna take them interruptions. We're gonna multiply by $1,000 to see how much they cost us. Okay. Then when we're done, because of this is a probability equation, we need an average and estimate to see actually on average, like what's the accurate number. So what we will do is that we will take the function, right, which is going to estimate the cost, but we will run this function multiple times, maybe for 10,000 times. So we're gonna call this function, we're gonna say maybe estimate cost. We're gonna call it estimate cost. We want to call it 1,000 times. So it's going to create multiple numbers here, like cost, maybe let's say it says 15,000 up to 10,000. Then when we're done, we take an average of these results. So we're going to say np dot mean of this entire thing. Then we return our results. Okay. I hope that makes sense. If you didn't understand this part, trust me, I'm gonna write an easy to understand code and everything will make sense. Yeah, just bear with me for a second now. So the point is that we have a simulate function, right? I'm gonna import the random function, which we're gonna use to generate the random time. So I'm gonna say generate random start time. Remember that they can start at any time, right? So start time. So we call this function and it does its simple thing. It's just gonna have to return a random dot uniform. Every number is the same probability of being chosen from 0. I want you to select 5 times 60 times 60. So this should be 18,000. Give me any second that you're gonna start from here. Okay. And then we have simulate simulate overlap. Then I'm gonna say number of interruptions. So remember that each interruption, each downtime, actually let me call it downtime, or I think it will be easy for people to understand. Number of downtime, each downtime cost us $1,000. So we want to simulate this because they said that they want the cost for 365 days. So hence here, we're gonna say for I in range. Okay, I'm gonna say starting at 0, I wanna go all the way to 365. Okay, then I'm gonna call the first job A or job 1 equals to what time does this thing start? So I'm gonna call this function, right? It's gonna start its own. This is randomly generated. Then we say job 2. What time does it start? So it's gonna say, right? It's gonna start its own time. So this is job 2. So what we do now is that we ask ourselves if the difference of these two apps of job 1, um, job 1, we subtract job 2, right? We're taking apps so that we avoid having those negative values. If it happens that these guys is less than 3.6, right? Is less than an hour, the difference between these two is less than an hour, then we know that that's an interruption. It costed us money. So we're gonna say num of downtime plus equals to 1. For this specific day, we know that we had a downtime. Okay, so what we need to do then is that we're gonna have to return the number of downtime then times $1,000. That's fine, but then we still need to get in some sort of like an average, right? So what we're gonna do in this case is that we can say I'm gonna get all costs, so which is gonna be equals to, I'm gonna call this simulate function that we're given, right? I'm gonna call it for how many times? Let's do it 10,000 for I in range of 10,000, 15,000. I don't know how long this thing will run. Then I'm gonna say the average. So I'm gonna actually return it. Just why not just return, or just, I don't know if it will call this function. Anyway, let me just do this. Let me just say npm dot mean, which is called all costs. I don't know how interview query works. Does it call this function which has to return this? I'm thinking of creating a separate function. Because I don't think it'll want to return something. So let's do this. What I'm thinking of doing is that let's create a function to actually do this for us. Actually, it's fine. I think it might call this name. I don't know how it works, but I'm gonna call this, and I'm gonna say estimate annual cost. So the reason I'm doing this is because I'm thinking that it might have been programmed to call a specific function in order to test if the results are correct. So because of that, I think I'll have to pass this inside this. It's going to be estimate cost. Then I'm going to call this function, and this function will then return, given that all cost is a global variable. So with that, I think this is the solution, guys, that we derived. So as we can see that this is an estimated cost at the end of the day, but we needed to make sure that there's a probability with regarding to the downtime, so that our estimates are quite accurate, so they're not just at random. So yeah, I think that's that. So I think this will be my last video. So I'll make more videos. I think we'll cover the next video that I would like to cover is the reservoir sampling. It's also one of the coding challenges that I would like to cover more in more details. And yeah, we're gonna look at more. Yeah, I'd like to hear your feedback, and yeah, see you next time. Thanks. Bye.